Figure 13.7, attempting to invoke derived class only functions via a base class pointer. It turns out when you're dealing with a base class pointer that's aimed at a derived class object, you can only invoke base class functionality through that pointer. And one of the reasons for that is the compiler cannot guarantee what the pointer is going to be pointing to at all times. So when you have a base class pointer and you attempt to invoke derived class only functionality, you will get compilation errors in that case. So to demonstrate, at line 9 we've created a base class pointer, and at line 10 and 11 we've created a derived class base plus commission employee object. We then take our base class pointer and aim it at our derived class object, which, as we demonstrated previously, is allowed because, again, as you go right side to left side across the assignment, you are going up the hierarchy of classes. So a base plus commission employee is a commission employee, therefore that assignment is allowed. Now, here at lines 16 through 22, we have a section of our program where through that base class pointer, we are calling base class specific functionality. So get first name, get last name, get social security number, get gross sales, and get commission rate. These 5 member functions were all defined in class commission employee. So the compiler is going to allow all of these member functions to be called via a commission employee PTR, a commission employee pointer variable. Separately, however, lines 26 and 27 will not work, and as you can see, they're getting the red squiggly error message lines in Visual Studio here. And in this case, it says commission employee has no member called get base salary, and similarly, it has no member called set base salary. And that's because when the compiler looks at these two expressions where we're attempting to invoke member functions, what it's doing is looking at the type of the pointer. It doesn't care what the pointer points to because that can change dynamically at runtime. So it looks at the type of the pointer, and based on that, it goes to that class definition, which is commission employee, and it looks only there to see what functions are available. And of course, commission employees don't have base salaries, so there is no get base salary and there is no set base salary. And when we attempted to compile this program, the error messages that came out are shown at the bottom here, and we can see here get base salary is not a member of commission employee and set base salary is not a member of commission employee either. And in both cases, it's telling you to go look at the declaration of class commission employee, so we can go ahead and do that. And if you take a look at the public interface of this class, you can see that there are no set and get base salary member functions. So again, through a base class pointer, you can invoke only base class functionality, which turns out to be a key aspect of polymorphic processing. So back in the previous lesson, for example, we talked about the shape class hierarchy. And in a shape drawing program, what you might have is some sort of a collection of shape objects. It could be pointers to shapes, whatever it happens to be. You would probably want to be able to walk through that collection one object at a time and tell every object to do the same thing. In this lesson, we're going to be looking at a payroll system in which we have a bunch of different types of employee objects, and we're going to want to walk through a collection of those objects, and for every employee we're going to want to calculate the employee's earnings. And when we do that, based on the type of the employee, we want the right earnings calculation to be performed. What we're showing you so far is that when you use a base class pointer, you always get the base class functionality. But with a concept called virtual functions and polymorphism in C++, we can tell the compiler that we don't want to make a decision on which function to call until runtime, what we call dynamic binding. And by doing that, at runtime, it's able to look at the type of the object and figure out the appropriate version of a given function to call. And that's what we'll be focusing on moving forward in this lesson.